Hello, 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 hello. The last stream, I'm not sure why OBS was. I had started streaming a live, and I was in perfect rant mode. Okay, as in the rant was good, and the words were. I was spitting fire basically, and the words were coming good, and there was no in between. But damn, when I checked the stream, no noise, man. And then I had to stop the stream. I was not sure what was happening for the firstly because in OBS the indicator seemed to be working fine, and then I had to restart my not restart re add my voice source, and now this is working fine. I don't know whether I can repeat that rant again or with that flow and that smoothness, but anyway, the gist of that was I was this particular modeling, right? It is like an architect. You are basically like an architect who is trying to model with your variables and with your constants the flow of water, right? But I have been working. I had worked on something similar before, and I was not able to understand it properly, make models properly, and all that. So there is uh, some sort of failure that is associated with this particular things that I'm doing, which crops up as your intimidation when you again see the same problem, right? So that is one of the reasons I'm kind of hesitant. But anyway, the as I was saying before, the main point of doing this is, of course, to enjoy. And this you should be anyway doing, right? If you're not enjoying, what is the point of doing it? So this this thing I should never forget, right? As in that will only stay because things will get harder. Some days will be very bad, and you will not be able to move forward. Yesterday was delightfully good, right? As in I was able to understand the frame buffer easily. Then I was able to scale things easily. This was all very good, but all days might not be the same, right? You will have, but the point is, if you take this as something very heavy, very intense, you will not have the motivation to come back to it, right? But this is myself enjoying expressing myself there and using your logic and your questioning power to actually understand this particular problem, right? So that is how you should be approaching it. Otherwise you will get intimidated, but because these problems are not as similar to your particular coding problems, right? As in this is a bit mathematical as well, and and there is a visualization aspect to it as well, and some of the concepts you might be reading for getting accustomed to the for the first time. So enjoyment is easy, even if you make a 0.1 percentage improvement or 0.01 percentage improvement, you should be actually enjoying it. Then only there will be enough motivation to come back to it and then do it again. So yeah, I think this was the different version of the preaching rant that I had done before. So yeah, I'm checking whether a voice is coming on the live. Otherwise, I mean, there is no one who is actually who can actually say that. But at least I have to check for myself. Otherwise, I mean, anyway, there are zero viewers, but still, at least you will be happy that there is actually a possibility that someone comes and sees this, right? So you're working for that possibility every day. So say that, but at least I have to check for myself. Otherwise, I mean, anyway, there are zero viewers, but still, at least you will be happy that add my voice source, and now this is working fine. I don't know whether I can repeat that rant again or with that flow and that smoothness, but anyway, the gist of that was I was this particular modeling, right? It is like an architect. You are basically like an architect who is, yeah, I think voice is working. You would have heard it anyway on the stream. But so, yeah. So, yesterday, let us see where were we. And there is no sense of urgency today. I mean, it is late in the night, but you can add a bit of sense of urgency, I guess, right? You should I add? No, no, I'll not be adding a sense of urgency. It's already 11 o'clock. So maybe we will do within my normal uh, spacing out and wandering as the name of the uh, channel. Wandering me. This is not the what do you call? This is not your sense of urgency. Me. This is my wandering and wandering and wandering me. This is my wandering me basically. So yeah, I'll do with that. Yesterday we had a lot of questions, right? Write down the algorithm to just solve this for rectangular droplets falling into rectangle cup. Yeah, this is the first thing that we had to solve. How will the droplets fall down? How will the droplets move sideways, right? And animating the drop moving down without collision on reaching and make sure it exists. This is something we can do now itself without thinking about any algorithm. Improving the identification of water droplets, because currently there is some noise elements that is coming up even when you use, if you see the images closely. Yeah, I was able to see it on my phone screen, but I'm not sure whether it was very visible on the stream. But my point is, uh, the we were able to see certain noises, which was kind of a slight marker indication of the pipe as well as the cup, right? And while we were trying to just recognize the water droplet, so like you can see through slides, shades, the water cup as well as the tap. So this was a kind of a thing that we need to improve, because that wouldn't look good in the final animation. And also we need to find the box, which is the texture coordinates of the cup. This is also something that is very required, because in a way we can do a faster computation if the water droplet is not within the box, and we can do a faster computation which is a bit lengthier, a bit heavier on the um, box basically. So this is how things are going to be, I guess. But yeah, working through this is not pretty easy. Currently at 11 o'clock, I don't think it is easy at all, because all of this seemed to be very intimidating. I'm not sure how I'm going to approach this. I can smile, I can laugh, I can say enjoying like 100 times. These all look pretty intimidating. Uh, so this is how things are, I guess. What should I do now currently? I think we should start off with the thing that we are kind of scared of anyway. This is the modeling of the water droplet. Uh, so let us quickly write it down, right? As in, without whatever comes to my mind, I'll just quickly write it down, and then maybe you can try and improvise from there further. This is like I'm writing an article or something, but anyway. If the water droplet is not within the cup, the water droplet moves down. No, no. So if the pixel is not within the cup, if the water droplet is present above, if the pixel is not within the cup, if water droplet is present above, then render current pixel with water above. This should be noted. It should be noted that it should be rendered with the water above, because it can be of many shades, right? So that is important there. Now this is the easier part. If the pixel is not in the cup, the most easiest part you can do. Uh, if it is empty, if it is empty, leave it as empty. The pix the pixel is not within the cup. If the water droplet is present above, render current pixel with water above. If it is empty, leave it as empty. If the pixel is not within the cup, if the water droplet is present above, render current pixel with water above. If above is empty, current pixel is empty. Okay. This is this is the important part. If the pixel is within the cup, now this part is extremely difficult. It's not extremely difficult. For each pixel, if the current cell is empty and the above cell is the current cell is empty and the no, this is also not correct. So what all can happen, right? Water can come diagonally into your space from either the left or right side, which is what happens if there is an obstruction that is present, which is again a water droplet. So that is possible. Or water droplet can come from above. So these both cases are possible. So, but for the water droplet to come diagonally in, what is the criteria there? Acha. If all pixels are empty, I think so. One thing I need to check is, are if conditions going to slow down the computation? What type of computations are faster in a shader, right? So we should be transferring the problem into that particular style. Whatever types of thing are is faster in the shader, we should be transferring those things to the shader basically. The pixel is not within the cup. If the water droplet is present above, render current pixel with water above. If above is empty, current pixel is empty. If the pixel is within the cup, if all pixels are empty, if the pixel is within the cup, if all pixels are empty, within the box, right? It's not. Uh, if the pixel is within the cup, let's keep it simple. If all pixels are empty, if all pixels above are empty, if current pixel is empty, then irrespective of what happens, current pixel will stay empty. If all pixels are empty, 1 second. 1 second, I will be back. Yeah. So if the pixel is not within the cup, the droplet, water droplet is present above, render current pixel with water above. If above is empty, current pixel is empty. If the pixel is within the cup, if all pixels above are empty, if current pixel is empty, current pixel is will stay empty. Okay. If current pixel has water, then it is an issue, right? So water can come to a particular pixel via four cases, right? One from the right diagonal above, just above, and right diagonal, left diagonal above, and one water is already present there, right? So which water droplet is coming to that pixel one, and second is yeah, which water droplet is coming to the pixel, or is it coming at all, or is it going to get emptied, right? Um, in case there is already water droplet there, or yeah, or the water droplet there actually moves down. The pixel is within the cup. If all pixels above are empty, if current pixel is empty, current pixel will stay empty. That's all. Okay. Great. Um, okay. The pixel is within the cup. All pixel above are empty. If current pixel is empty, current pixel will stay empty. Okay. Now I think so. We have written down all the easiest things in this. That's a start. Uh, so, what is the case in which a water droplet cannot move anywhere? Right, the water droplet that is present in the current cell cannot move anywhere. If current pixel has water, if current pixel has water, what is the case in which we are sure that if this is not a subcase of that, if all above pixels are empty, right? Because even if all pixels are not empty, if current pixel has water and it cannot be what you call, it cannot be vacated, then it will be there present anyway. So we will add this as a outer condition. If current pixel has water, um, if diagonal left and diagonal right below has water, okay, as in the water cannot spread, at least currently. If diagonal left and diagonal right below has water, and if so this is a complicated model that I'm building. It's an unnecessarily complicated model that I'm building, but no second guessing. So this is something I have to first go through the whole model first. Then I have to make sure that it is optimized, right? Yeah, I could have done an easier model with like 30 without using shaders, with just which I have already done. Just directly using a matrix. But uh, yeah, current pixel has water. If diagonal left and diagonal right below has water, current pixel has water. Diagonal left and diagonal right has water. And the connected connected down water index has obstruction, then water will remain. What is this connected down water index, right? As in, so suppose you have an index xy, and suppose the uh, n water droplets below is also n pixels below also is water, and n plus 1 is not. Then the connected down should be y n plus 1, y plus n plus 1, basically, right? So this is basically to check that every time we are able to get obstructions, right? As in, if things were done sequentially, this wouldn't have been a problem, but things are not done sequentially. So yeah, this will remain a problem. Now, how will this merge is a question, right? As in, suppose water droplet moves down, how will this merge or evolve, right? This is something that is going to be important now. So this data structure connected down has to be updated, I guess, all the time. And the connected down water indexes has obstruction, then water will remain. Great. Yeah, this is great. Now, I think we have to work on this connected down. If then else, this has to be the first condition to check, to be checked, by the way. This has to be explained in a better manner, I guess. But first, let's think it through, then we'll just explain it. Think it through, then we'll just explain it. Half an hour is okay today, right? As in, I think we have to go through the whole algorithm again, and no, we'll complete it. Or should I? Body is paining also. I did. So I mean, so the seating arrangement is not that great. So maybe we will do this. The rest of the thing. At least we did the half an hour thing. We will do the rest of the thing tomorrow. As in, we have started with the algorithm, and we can complete the algorithm tomorrow. As in, when I'm more refreshed. This was just to make sure that I start working on the problem. Now, since I have started, I think things can go through. So yeah, it's a bit lazy on my part, but yeah, I think it's fine. I guess this 5-10 minutes here and there wouldn't matter. In the end, consistency would matter. So yeah. Anyways, then I'll see you tomorrow. Then we have started working on the problem, so which is good. So we'll then continue working on this. Bye then. Bye. Bye. Bye.